This is an introduction and syllabus overview for ASU Online Chemistry 343 students for the Fall 2022 A session. Students enrolled in this course will be able to access through ASU Online the ASU Canvas LMS system, and in this you should have a tab for the Fall Chem 343 online laboratory. When you access this, the first thing you'll see is the course syllabus, which we'll cover in a second, course deadlines. There's a couple bookkeeping that you've read the syllabus and taken a quick quiz, and the academic integrity, and then list of the deadlines for the various projects in this course. And then finally, while participation is weekly, the final deadline for completing all weekly participation through Yellow Dig is at the end of the semester or end of this session. Announcements will be provided here for the course. They'll also be repeated oftentimes on Yellow Dig, which is where most of the laboratory communication will happen for this course. But most major deadline announcements, etc., will be posted here. Yellow Dig is the social communication where participation weekly will be expected for peer-to-peer interactions, asking questions regarding the lab, polling, covering the various topics that we'll be covering in this laboratory, and being able to ask questions, respond to questions, answer polling questions with both the instructors and peer-to-peer. And this will be evaluated weekly, and points are given for providing comments to questions, answering polling questions, etc., and is passed back into here. The modules for here, at the first of the course, there's some overview of what Yellow Dig is. Welcome to this course. Zoom is how instructors will primarily correspond with students, and how students can also correspond with each other in this course remotely. I have an external website for all publicly available material, and again, completing these. Then we'll start with, there's three primary modules. These three modules cover the topics that are done in 341, which is starting with basic molecular or gas phase thermodynamics, moving on to thermochemistry, and then chemical equilibrium kinetics. And then these also have reports, peer review, and revision stages associated with it. The date associated with this is the initial due date of the report. The points here represents the report and the peer review of each of these. And then finally, we have a Project X for either people who skip one of the other projects or want to specifically focus on some more developmental and quantum-based chemistry. And then finally, Module 5 is just the pass-through for the Yellow Dig participation, which is done throughout the semester. What was given on the first one is similar to here, all the different assignments and some of their due dates. Zoom is where you will find meetings, both for remote lab assistance, as well as kind of office hours, grades, obvious, files, anything proprietary that we need to communicate. This does require significant amounts of laboratory or library resources. Dictation is a tool that can be used if you're trying to create videos or annotate material as a presentation means. So that's kind of an overview there. Let's go back and now overview the syllabus for this course.
So when we look at this is a PDF of the syllabus, which can be found on the remote public site, biopchem.education, or on Canvas. As I said, recitations and stuff and material, the primary way of will be video conferencing through Zoom. Instructor, the primary one will be myself and my contact information, a teaching assistant, Bantry, and then mostly Sean is behind the scenes doing a fair amount of development work to make this, to constantly improve the remote and cloud nature of this laboratory. As I said, it's primarily your first stop is Canvas, and I also make any and all of the publicly available open source material on this public website as well. The prerequisites for this lab is that you're either currently enrolled or have you completed the physical chemistry course, either with a biological focus, BCH 341, or Chem 341, elementary physical chemistry, or the equivalent at another institution. And that's critical because these are meant to be computational, experimental laboratory data and error analysis associated with the material that's covered in these courses. Because this is an online remote lab, the primary requirements for this are IT related, mainly good internet speeds, HTML5 browsers, VNC for remote access, video conferencing through Zoom, and most of these can be found at myapps.asu.edu. There is no, the course is designed to be as asynchronous as possible, not requiring specific time and dates for people that are remotely in different time zones, etc. So most of what would be covered in a recitation will be done through online screencasts and videos that will be posted. And the labs are meant to be, the remote labs are meant to be as asynchronous as possible. That said, getting together in groups is often very helpful, and we will try to find some times where the majority of students could work together in a kind of a remote synchronous way as well. It's a fairly standard evaluation for this course as far as grades go. As far as what will be produced to evaluate in this course, the primary thing is that the projects, and I call them projects and not laboratory or exercises, because they're not like a lot of labs where it's come in, follow a recipe, do one thing, move on to the next, etc. This is really meant to be where you're doing computational, experimental data analysis, you're doing multiple components all on the same project or physical chemistry topic, and you're peer reviewing those. Then you're also having a chance where you can revise both the data analysis as well as the computational or even experimental components of this and turning it back in, etc. This limits the number of laboratory projects to at maximum 3, and it's possible to get all the points just doing 2 of the projects. The laboratory projects is linked to the peer review. These are peer reviewing of anonymously and randomly assigned peer review of the reports that are submitted by students, and you will be evaluated on the quality, substance, and accuracy of your peer review. So the instructors will act like editors would. I consider this a critical process. Reports, outside of
undergraduate academics usually take the shape of manuscripts and stuff, and these are often peer-reviewed. In fact, it's the standard for scientific publication is that it undergoes anonymous peer review. So becoming a good peer reviewer, as well as using peer reviews to improve and produce quality reports and manuscripts, is a key component of this upper division laboratory. The last one is what usually distinguishes laboratories from a lot of lecture-based courses is getting together and participating in groups and teams and working together and working in a lab with other people. So to try to emulate some of that and bring some of that online, we're using YellowDig so that you can participate in, make comments and help each other out online and asynchronously. But the goal is also that that will be the platform that will allow you also to maybe synchronously come in and work on these remote labs together in groups, etc. So this works a lot like a social media group platform, like a WhatsApp group or a Facebook group, etc. And you can post videos, pictures, make comments, etc. Links, schedule times, take polling questions, etc. for this. And the major difference on YellowDig is that it keeps track and gives points for different types of participation, like comments and posts and answering polling questions, etc. You can get points every week, which you can get a maximum of 150 points for participating weekly in YellowDig. And this should be by checking and participating several times per week, you should easily be able to get the maximum points allowed for the participation component. That totals, those are the major components for what you'll be evaluated on. And these will be done in kind of several projects in a row, where we're starting with molecular thermodynamics and property of gases. All of these projects have 3 major components. They each run about 2 weeks each, and they have a computational, where you can remotely do computational exercises or experiments, remote laboratory experiments to collect data, and then in a sense data science or data and error analysis components. They're all fairly equally weighted in here. And then finally, the review and revision components are also a key aspect to this. So this gives kind of some of the overview dates and precisely when the project reports, the peer review, the revised report, any revised peer review comments, and your editor or instructor-based peer review evaluation will be for each of the 3 major reports. So there's also the last week, either for somebody who's missed some of these or wants an additional laboratory to make up. We have a Project X where there is a due date to do an outline for this. It would be treated like any of the other projects, except the peer review would come from the instructor instead of from your classmates in this. And I've given several examples, but that's the whole point of the proposal. You can propose remote experiments, either DIY or remotely accessible at ASU. These are some that we have available. And do a project that's a more independent project that we call Project X. So information about that's given here. The projects are primarily evaluated through project reports. Of course, the most traditional is a written laboratory report that mirrors a scientific manuscript or publication. And because that's the most common, it's also what I give a rubric for in this syllabus. However, besides common reports, which often students have some familiarity with, a modern way to report experimental and computational laboratory exercises is through, for example, digital notebooks like Google Colaboratory, where you mix both the text and the data analysis into one, or something like Mathematica. You can do it as kind of a presentation, often where you screencast it with audio annotation, kind of like I'm doing here. You can do a type of web blog or dashboard, kind of like you would present something in a data science program like Kaggle. You can do a scientific poster, which is, for the most part, storyboarding through figures, but also figure captions, introductory text, and instead of it being page by page, it's storyboarded out on one large poster. Something like memos, which I give an example of, and screencasts, etc. So there are several ways that you are welcome to other formats besides standard written laboratory reports that you can turn in for these various laboratories. As I said, the common written laboratory report is the most common, and so it's the one I give an explicit rubric for here in the syllabus, where I break down even point-wise where things would be evaluated. The last thing I want to say, which is a bit of a change, is one of the things in scientific reporting, scientific manuscripts over the last 10 years that is significantly changed is now that everything has gone digital, where the number of pages and space taken can be greatly expanded compared to old, basically hard copy journals, where the space was fairly limited what you could include. And this has led towards most scientific manuscripts having supplemental information, oftentimes which is much more detailed than what's included directly in the scientific manuscript or report, and shows a lot of the detail and is often quite significant as far as how much information is included there and just referred back to in the normal report. This is especially true in something like physical chemistry lab, where you have a lot of calculations that can be explicitly shown. Same with your error analysis and propagation of error. Even oftentimes you show kind of a summary figure or an example figure in the report, and you might want to include several of the additional things measured or done in this supplemental information. And so while this is typically, as included here, referred to and given 10 points, the substantial nature of this for students who put in the effort to really report and show all of their calculations, additional figures, and kind of explicit details, then this can have, in a sense, an extra 50 points, which more or less means that if you do 2 reports with significant supplemental information, then you can complete the reporting requirement for this course with 2 full reports with full supplementals instead of 3 project reports with more abbreviated supplemental information. So the peer review is talked about here, and there'll be several pieces of information given. This assumes that the peer review would use the rubric from the written report information given above. There will also be information given to peer review for students who use a different format for their report, for example, either notebooks or a presentation style, etc. They will be distributed within 12 hours of the due date of the initial report in Canvas. These reports are randomly assigned to two peer reviewers that are kept anonymous, and you're given 1 day to evaluate those two assigned reports and provide detailed comments and evaluation via this peer review process. And this is all done within the turning in the project or assignment within Canvas. It has a peer review component to it where you can leave comments directly in the Canvas project assignment for each of the various report projects. And then finally, as I mentioned, laboratory participation in this idea of really trying to build a community, even though we're all remotely scattered out, trying to bring us together through technology, through interaction, through social communication is emphasized in this course. Helping your fellow students out, participating by helping answer questions, by polling, etc., will all be done through Yellow Dig, and it will be points given every week with a maximum of 150 for participating. So this is something that is a significant component of your grade, and hopefully emphasizing that we're trying to make these laboratories like in person where it really builds engagement. So that's the primary components. The other half of the syllabus is a lot of the general policies, which I'm not going to cover explicitly in this video. So hopefully that provides a quick video overview for the fall 2022 semester, and I look forward to seeing all students in this online course. Thanks.